Hi all, our project is on HR analytics and my team members are myself, Srinandini, Karnakar, Dharman and Pratik. Moving on to the introduction, this report explores the significant challenge of employee attrition using the IBM HR analytics dataset. In today's corporate environment, comprehending and addressing employee turnover is essential for ensuring organizational success and longevity. The analysis endeavors to reveal underlying trends and factors influencing employee attrition. Moving on to objectives, specifically, our analysis aims to address the following two objectives. The first objective is framed based on education level and attrition. So basically, we were trying to answer the question, can employees be classified into attrition and non-attrition groups based on their education levels? The second objective is based on role, education, and company history in attrition. For example, for employees with higher education levels, can they be categorized into attrition and non-attrition groups based on their role within the company and the number of companies they have worked for? The data we used for our employee attrition analysis is IBM HR Analytics data, and it has around 1470 entries with 35 features. So the key features include demographic information like age, gender, and marital status, and it also has information regarding work-related details such as business travel frequency, daily rate, department, job role, and so on. Employee satisfaction ratings were also there, and it does have financial attributes such as hourly rate, monthly income, and stock optional level. It also had information regarding career progression indicators like total working years, years at the company, and years since the last promotion. Next comes our methodology and how we did our analysis. The very first step in the methodology is data preparation and cleaning, where we found our initial insights of the data, including distributions and handling of missing values, is done. And moving on to the exploratory data analysis, further examination of job roles, departments, and attrition rate columns is being done here. In statistical analysis part, we did some in-depth statistical tests and correlation analysis to understand the data better. And in predictive modeling, we also created some predictive models using logistic regression and discriminant analysis, post which we found out its results and provided some powerful interpretations out of it. Thank you.
So hello everyone, my name is Pratik Kaushik and we'll be talking about the data preparation and data cleaning. So our data set contains 1,470 observations with 35 features, providing comprehensive information about employee attributes and their status within the company. Features, numerical features include age, daily rate, distance from home, education, job level, monthly income, and so on. And the number of observations are all employees are over 18 years old, as indicated by the over 18 column. No missing values are reported, suggesting our data completeness. Immediate data inconsistencies or unusual outliers are not evident, but further exploration transformation are planned. Thank you. So now in the next slide, we can see the initial data exploration with the QQ plot for age and QQ plot for distance from home. So a QQ plot for age is basically a graphical tool for assessing the data distribution, comparing the observed age data with theoretical normal distribution. And straight line indicates that the approximate normal distribution and the data is normally distributed overall. And if we talk about the normal QQ plot, the normal QQ plot for distance from home is basically specifying that evaluating the distribution of employee commuting distances, comparing the observed distance with theoretical normal distribution, and helps understand commuting patterns and location preferences. So coming to our next QQ plot is for monthly income, which is assessing the distribution of monthly income among employees and comparing the actual income distribution with theoretical normal distribution. And it is useful for identifying income disparities and understanding the salary structure. The next QQ plot and the fourth one is between the number of companies worked, basically examining the distribution of employee providing previous work experiences and comparing the actual distribution with the theoretical normal distribution, and helps identifying patterns in job mobility and tenure among employees. So after the QQ plot, we have the handling missing values from the dataset, because until unless we don't handle the missing values and the outliers, then our analysis will be incomplete and might hamper the process of actual results. So in the data processing stage, several steps are taken to handle missing values like effectively. And initially, a mode calculation function called get mode is defined to determine the mode of a vector efficiently. Subsequently, missing value in numerical columns are imputed by replacing them with the median of their respective columns and ensuring the robustness in handling outliers and maintaining the central tendency of the data. As you can see in the table, we do not have any missing values, and such as like missing values in categorical columns are addressed by replacing with the mode, and which represent the most frequent value in each column. Following the imputation process, a summary is generated to verify the absence of any remaining missing values, affirming the completeness and readiness of the dataset for further analysis. Now let's talk about the data transformation and coding. So wherein they both play a crucial role in preparing the dataset for our analysis. So in this step, the categorical columns are encoded to numerical format using the vector method. First, a vector named categorical (COLS) is defined to hold the names of categorical columns, and then each categorical column is encoded as a factor, and ensuring the compatibility with various statistical and machine learning models that require numerical input. So finally, the transform dataset is inspected to ensure that the encoding process has been applied accurately with the categorical columns and represented as factors. So this preparatory step ensure that the data set is appropriately formatted for further analysis, facilitating insights into the relationship between different variables and enabling the applications of advanced analytic techniques. So now let's talk about the exploratory data analysis, which is topic number four. So demography analysis we have in the EDA. So in which we analyzing the workforce composition by age, gender, education, and marital status provides insights into employee demographics. And next one we have in the EDA is job role and department analysis, wherein we examine the distribution across job roles and departments and identifying popular roles and key operation areas. The third one would be attrition rate analysis, where we study the employee turnover rate and identifying the factors influencing attrition. And the fourth one would be in the EDA would be correlation analysis, wherein we are exploring the relationship between variables and uncovering the association between factors like job satisfaction and performance, age distribution. So wherein the employee characteristics like age, gender, education, marital status offering profound insights into the composition of the workforce. Among these phases, we have this age distribution stands out as a significant metrics, shedding light on the demographic makeup of the organization. The visualization of age distribution provides a comprehensive overview of the age ranges prevalent within the workforce, enabling a deeper understanding of workforce diversity and age-related dynamics. By examining the distribution of ages across the organization, we gain valuable insights. For example, generational composition of the workforce and its implication for various HR strategies and organization initiatives. So overall, the histogram of age distribution reveals a right skewed pattern, indicating that a larger proportion of employees are younger, as you can see in the screen, and the majority of employees fall within the age range of late 20s to early 40s, with a peak frequency around the age of 35. So this suggests that the organization workforce is relatively young. So for the next visualization, the demographic analysis is the gender proportion, wherein we can see that looking at the bar chart, it's clear that there are more men in the organization as compared to the women, and this difference is quite big, meaning that there are many more male employees than female ones. This tells us something about the types of jobs in the industry or how the company is actually hiring the people. Now let's talk about the job role and department analysis, wherein we can see the different colors for the bars representing different job role. So this section basically delves into the distribution of employees across different job roles and department within the company, within the organization, basically. So if we talk about the distribution of job role, then by examining the bar chart, we can see that a diverse array of position within the organization. The most common roles are sales executive and research scientist, indicating that these areas are central to the company's operations. And on the other hand, roles like human resources and healthcare representative have fewer employees, suggesting a very few strength of the workforce, suggesting a more specialized or niche requirement in these areas. So basically, this suggests that the sales activities and research initiatives are key operation pillars for the company, and conversely, roles such as like human resources, commonly known as HR, and healthcare representative are less common, indicating a specialized or limited requirement within these areas. And understanding the distribution of job roles is pivotal for resource allocation, recruitment strategies, and identifying potential skill gaps. So if we talk about the distribution of job roles with the bar chart that we have plotted, so we can see a diverse array of position within the organization. The most common roles are sales executive and the research scientist. Uh, so sales executive basically belonging to the sales department, and research scientist basically belonging to the R&D department, indicating that these areas are central to the company's operations. And on the other hand, roles like human resources and healthcare representative have fewer employees, suggesting a more specialized or niche requirement in these areas. So in our next visualization, we have the distribution of departments bar chart, basically, which is depicting the departmental distribution. Highlights that the research and development (R&D), commonly known as department, has the largest workforce, followed by sales. And interestingly, the human resource department is the smallest, which aligns with our findings on the job role distributions. So this dominance of the research and development department might signal the company's primary business function and or industry focus, basically. And the distribution of employees across different departments provides insights into the organization structure and operation focus. The R&D department stands out as the largest, housing the majority of the workforce. This dominance underscores the company's commitment to research, innovation, and product development, possibly reflecting its core business function. And following closely is the sales department, indicating a significant emphasis on the sales and revenue generation, basically. In contrast, the human resource department emerges as the smallest one, as mentioned already, and aligning with the distribution of job roles. So this distribution pattern offers valuable insights into the company's strategies, priorities, and departmental composition. So, yeah. So if we talk about our next visualization, which is job role distribution by department, so overall, uh, sales executive roles are exclusively found in the sales department by looking at the bar chart, so indicating a specialized function within the department. Conversely, research scientists in the R&D department position are predominantly concentrated within the R&D department, emphasizing the alignment of role with the department focus. And certain roles such as HR are contained within their respective department, as indicated by the distribution. So this visualization offers valuable insights into the organization structure, delineating how job functions are distributed across various departments within the company. So finding the relationship between job roles and department, the visualization of the job role distribution provides a comprehensive overview of how responsibilities are allocated across different organization units in the single organization, and it elucidates the specialization within each department, with certain roles being exclusive to specific areas of the company. Moreover, this analysis highlighting the cohesion between the job function and the departmental focus, offering valuable insights into the organization function, division, and operation practices. So yeah.
Hello, I am Karunakar and I will be continuing the analysis. Let's dive into our attrition rate analysis. As illustrated in the graph, there's a noticeable smaller segment of employees represented by years, indicating a lower attrition rate. This trend suggests positive employee retention from an organization standpoint. Following that, we generated a correlation chart to explore relationship within the dataset. Notably, years at company, years in current role, and total working years exhibit robust positive correlations, which is also noticeable in the graph. This suggests that longer total working hours generally align with extended tenures within both the company and the current role. Now let's move on to statistical analysis. In this analysis, we will address the hypotheses relevant to our objectives along with descriptive and inferential statistics. Hypothesis testing. We generated two hypotheses to analyze each of our objective. The null hypothesis for our objective 1 is there is no significant difference in attrition rate among employees with different education levels. And the null hypothesis for our objective 2 is for employees with higher education levels, job role and the number of companies worked do not significantly predict attrition, and alternative hypothesis being opposite to that. Descriptive statistics education level. The histogram shows that bachelor's degree is the most common, followed by master's degree and then some college level education. Very few employees possess doctorate level education, and at least all of them have some college level education. Descriptive statistics number of companies worked. The histogram shows that most of them have worked in at least one company before, and there is a decreasing trend as the number of companies worked increases, indicating that very few employees have worked at many different companies. Moving on to the inferential statistics, the first one being t-test on education by attrition. A Welch 2 sample t-test was conducted to compare the mean education levels between employees who have left the company and those who have not. The p-value was found to be 0.2242, which is above the conventional alpha level of 0.05. This indicates that there is no statistically significant difference in the mean education levels between the two groups at the 95% confidence interval. The mean education level for the no group is 2.927 and for the yes group is 2.839. The no and yes are for the attritions. Then Pearson's chi-square test was performed to assess the association between job role and attrition status. The test yielded a chi-square value of 86.19 and a highly significant p-value of 2.72 into 10 to the power minus 15. This strongly suggests that there is a significant association between an employee's job role and their attrition status. Moving further with the analysis, we conducted ANOVA for a number of companies worked across education levels. The results indicated significant differences with an F value of 7.082 and a P value of 1.2 into 10 to the power minus 5. This suggests that the number of companies an employee has worked for varies significantly with their level of education. A logistic regression was used to model the probability of attrition based on the number of companies worked and education level. The model found that the number of companies worked was positively associated with the likelihood of attrition. The p-value was found out to be 0.0648. Although this association did not reach the traditional level of significance, which is p-value of 0.05, education levels, when treated as factors, did not show a significant effect on attrition in this model.
The logistic regression model examines the impact of education on employee attrition. The intercept and education coefficient are statistically significant, with p-values indicating a less than 0.05. Chances of observing such an extreme effort by chance will suggest a genuine relationship in the sample data. The model, however, exhibits a lack of specificity and a low kappa value, meaning it does not predict actual attrition well and agrees with the true attrition status no more than random chance. An extremely low McNemar's p-value indicates a significant imbalance in the model's classification errors between the two classes. Despite an accuracy of 83.92, the model's practical utility is questionable due to its inability to predict any positive case of attrition, as evidenced by the confusion matrix. The model focuses on the influence of job role and the number of companies worked on employee attrition among those with higher education. Significant coefficients of several job roles and the number of companies worked suggest that these are important factors in predicting attrition. The accuracy of the model is over 80%. But like the first objective, it lacks specificity, it does not correctly predict the actual case of attrition. The low McNemar's p-value again points to a significant bias in the model, which is good at predicting the majority classes, which is the non-attrition, but fails at predicting the minority classes, which is the attrition. The positive coefficients for job roles suggest that the employees in these roles are more likely to leave according to the model. But given the lack of specificity, these findings should be interpreted with caution. The random forest model built with 1000 trees aimed to predict attrition based on education, showing an out-of-bag error of 16.12%. The confusion matrix indicates the model's perfect prediction for non-attrition, but a complete failure to predict any attrition cases, leading to a 100% error rate for actual attrition predictions. Variable importance measures reveal that education level does not significantly impact model's accuracy, with a mean decrease accuracy of 0 and a low mean decrease Gini value. These results indicates that the education alone is not a sufficient predictor of attrition in this case, and additional factors may need to be considered. The random forest model for objective 2 used job role and number of companies work to predict attrition, 1000 trees and 2 variables tried at each split. It showed a slightly higher out-of-bag error rate as of 16.59 compared to the model in objective 1. The model had a low error class for predicting non-attrition, but similar to objective 1, it is entirely failed to correctly predict attrition cases. Variable importance measures show negative mean decrease accuracy for both predictors, suggesting they might detract from the model accuracy. However, the higher mean decrease Gini value suggests these variables do affect the model's decisions regarding node purity. For Objective 1, both LD and QDM models predict no attrition cases correctly. All individuals are predicted as non-attrition, resulting in a sensitivity of 100% but a non-specificity of 0%. In Objective 2, the LD slightly improves, correctly predicting one attrition cases, while QDM markedly improves, correcting identifying 13 attrition cases. The LDM model for Objective 2 still shows a heavy bias towards predicting non-attrition, similar to Objective 1. However, the QDM model shows a better balance in prediction, being able to identify some attrition cases. We suggest that the quadratic approach may capture the complexity of the dataset better than the linear approach for Objective 2. The overall assessment would suggest that while some job roles and the number of companies worked may have an impact, the models are still challenged by the complexity of attrition prediction and may benefit from additional data or alternative modeling approaches. In summary, our final analysis concludes that for Objective 1, education does not significantly predict attrition, affirming the null hypothesis. However, for Objective 2, the role and the number of companies an individual has worked for are significant predictors, leading us to reject the null hypothesis. This nuanced understanding underscores the importance of job satisfaction and history over educational background in retention strategies. These insights are crucial for developing targeted interventions to maintain a stable and a committed workforce.